Today we are going to be solving absolute value equations, but before we start solving equations, we're going to go over the definition of absolute value. So the definition of absolute value is the distance a number is away from zero. So we're going to start off with the example of the absolute value of -2. Okay, so as I said, the absolute value is the distance a number is away from zero. So 2 is right here. So we want to count the distance -2 is away from zero. So -2 is 1, 2 spaces away from zero. So the absolute value of -2 is 2. Okay, and now we're going to try the absolute value of +2. So +2 is right here. And positive 2 is 1, 2 spaces away from 0. 2 spaces. So that is how the absolute value of -2 and the absolute value of 2 have the same number. They're both equal to +2 because that is the number it is away from 0. So that's why people always say what's inside the bars make the number positive, because the distance is positive. Alright, next we're going to actually start solving some absolute value equations. And we're going to work through our steps, which is written at the top, while solving. So step 1 says isolate the absolute value bars. That just means if you have anything on the outside of the absolute value bars, you want to get rid of it. So the equation that I have for number 1 is the absolute value of 6x is equal to 48. Since we have nothing directly around those absolute value bars on the same side, it's already isolated. So step 1 is complete. Step 2 says set the inside of the absolute value bars equal to the positive and negative number on the other side of the equal sign. So that just means what's on the inside of the absolute value bar, which is 6x, you want to set it equal to the positive and negative version, which is on the other side. So 48, the positive version of 48 is 48. The negative version is -48. Alright, so when you do absolute value equations, you're going to have two cases. The positive version, which is right here, and the negative version, which is right there. Alright, so now step 3 says solve both equations. So this is just a one-step equation. So that means we're just going to divide by 6 on both sides. So that x is equal to 8. Alright, so x is equal to 8 there. And we want to solve the other equation. Once again, we just want to divide by 6. So the x is now equal to -6. Okay? Sorry, -8. My mistake. All right. Now, step 4 says check the solutions for extraneous solution. Extraneous solutions are just when you plug the number back in and it's not true. All right, but we're going to check this to see if it works. All right. So I'm just going to plug it back in. And when I plug it back into the original, which is up here, I have 6 times 8, which is what I got here. And that is indeed equal to 48. So this is true. All right, and our next one we have is the absolute value of 6 times -8, which is equal to the absolute value of -48. And anything in the absolute value bars is positive, which means this is equal to 48, which means that is true. All right, so the solution to this equation is x is equal to 8 and -8. Okay, so we've done all of our steps, and that is our solution to our first equation. All right. All right, now we have an example 2, and we're going to do the same thing by working through the steps. So step 1 is to isolate the absolute value bars. As we see to the right-hand side, number 2 says the absolute value of 4x plus 2 is equal to 34. The absolute value bars are already isolated. Now we want to make our case 1 and case 2, and that just means setting what's on the inside equal to the positive number on the other side, and setting what's on the inside equal to the negative version of what's on the other side. So that just means 4x plus 2 is equal to 34, and 4x plus 2 is equal to -34. And now we want to go ahead and actually solve the equation. So I'm going to subtract 2 on both sides, so that 4x is equal to 32. And then I'm going to divide by 4, so that x is equal to 8. All right, so that's our case 1. And case 2, I'm going to do the same thing. I'm going to subtract 2 on both sides, so that 4x is now equal to negative 36. Then I'm going to divide by 4 on both sides, so that x is equal to negative 9. All right. Now I'm going to plug in my solution again to see if I get extraneous solutions and if I'm correct. All right, so I'm going to plug it in. So that 4 times 8 plus 2, the absolute value of that, which is equal to 32 plus 2, which is equal to the absolute value of the absolute value of 34, which is positive 34. So this solution is true. And I'm going to check the second one by plugging that in. So 4 times negative 9 plus 2, which is equal to negative 36 plus 2, which is equal to negative 34. And since it's in absolute value bars, that means it's positive. So that is now equal to positive 34, which is what we wanted. So this solution is true. All right. So our solution set is x is equal to 8 and x is equal to negative 9. All right, now we have our third absolute value equation. So if you look at the right-hand corner for number 3, we have negative 2 times the absolute value of x plus 3 is equal to negative 14. And our first step says to isolate the absolute value bars, and this is our first time that we're actually going to have to do that. Since I have a negative 2 on the outside of the absolute value bars, I want to get rid of that first before I can even make my cases. So we treat absolute value bars just like parentheses. All right, so if this was parentheses, we would say divide by negative 2, and that's exactly what we're going to do here. We're going to divide both sides by negative 2. All right, so that we have the absolute value of x plus 3 is equal to 7. And now that the absolute value bars are isolated, we can go ahead to step 2. Step 2 says to set the inside of the absolute value bars equal to the positive and negative number on the other side of the equal sign. So that just means our case 1 and our case 2. Case 1 is positive, case 2 is negative, and we're going to go ahead and do that. So I'm going to have x plus 3 is equal to 7, and I'm going to have for my case 2, x plus 3 is equal to negative 7. Okay, and now we're just going to solve this simple one-step equation by for the left side we're going to subtract 3 on both sides, so that x is equal to 4, and on the right hand side we're going to subtract 3 as well, so that x is equal to negative 10. And now that we have our solutions, we're going to go ahead to step 4 and check for extraneous solutions and check for errors as well. We're going to plug in our 4 and our negative 10 back into the original. All right, so I'm going to start with that 4 on the left-hand side by plugging in 4 for x. And this is what I will get. And we treat absolute value bars just like parentheses, so we solve what's on the inside first. So I have a negative 2 times the absolute value of 7. Since I have a positive number on the inside and I don't have anything else to do, I know I'm complete with that. So I can drop those absolute value bars and make them parentheses. Okay. So that I have negative 2 times 7, which is equal to negative 14. Since that is true as our original, this is our solution. So x plus 4 is one of our solutions. X is equal to 4. Sorry, x is equal to 4 is one of our solutions. Our next solution is x is equal to negative 10. So I'm going to plug that in. All right, we're going to solve the inside of those absolute value bars first. So that's negative 10 plus 3, which is equal to negative 7. Now I have a negative number on the inside of the absolute value bar, so I have to actually solve that absolute value before I can move on. And the absolute value of negative 7 is positive 7. All right, it's positive 7. Replace those absolute value bars with parentheses so that I get negative 2 times 7, which is equal to negative 14, which is the same thing as our original. So this is also a solution. So our two solutions for our equations is x is equal to 4 and x is equal to negative 10. All right, now we have our last equation, and that's our number 4. Now, once again, you always treat these absolute value bars just like you would parentheses. And when you have parentheses and you're solving equations, you always do addition and subtraction first and multiplication and division last. So I have a multiplication right here, and I have a subtraction right there. So I want to do that subtraction first. So that tells me I want to add 9 on both sides of the equal sign. All right, so that on the left side of the equation, I'm going to have a 5 times the absolute value of 4x minus 4 is equal to 40. All right, the absolute value bars are still not isolated, so we got one more step to do. We got multiplication right there, so we want to divide both sides by 5 so that we have the absolute value of 4x minus 4 is equal to 8. Now the absolute value bars are isolated, and we can go ahead to step 2. So step 2 says set the inside of the absolute value bars equal to the positive and negative version, and that's just our case 1 and case 2. We've done that before, so we're going to go ahead and start. So that's going to be 4x minus 4 is equal to 8, and 4x, I'm going to go down here, 4x minus 4 is equal to negative 8. Okay, now we're going to go ahead and start solving. So I have a plus 4 on both sides. I'm working on the equation on the left hand side. So that 4x is equal to 12, and then I'm going to divide by 4 on both sides. So that x is equal to 3. Okay, and then I'm going to do the equation on the left. I'm going to add 4 on both sides so that I have negative 8 plus 4, which will give me 8 minus 4. And then I'm going to divide by 4 on both sides so that I got x is equal to negative 1. All right, so we have x is equal to 4 and x is equal to negative 1. And we're going to check that solution to make sure that it works. All right, our two solutions when we solved our equation was x is equal to 3 and x is equal to negative 1. So we want to go ahead and start checking those solutions. So I'm going to go ahead and start plugging in our x to our original. And this is what I will get. I'll get 5 times the absolute value of 4 times 3 minus 4 minus 9. So I'm going to go ahead and solve the inside of the absolute value bars first, because that's what we would do if there was parentheses. And I have 4 times 3, which is 12, minus 4. And on the outside of the absolute value, I have a negative 9 right there. And on the inside of the absolute value, if I go ahead and solve, I'll have 8. And then the other side, I continue, I have 9. So we have absolute value bars. It's no negatives. It's no nothing. So we're done. So we can drop those and make them parentheses. And go ahead and solve. So I have 5 times 8, which is 40, minus 9, which is 31, and that's what our original said, so that is true. So this solution is correct, and there's no extraneous solutions. And then our next solution was x is equal to negative 1, so I'm going to go ahead and plug that in as well. On the outside, I have a 5, and on the inside, I have 4 times negative 1 minus 4, and the outside, I have a negative 9. So I'm going to solve once again the inside of those absolute value bars first, just like I would parentheses. I got a 4 times negative 1, which is negative 4 minus 4. On the outside, I have a negative 9. So on the inside of the bar, once again, I have negative 4 minus 4, which is equal to negative 8. All right, and I'm going to continue to solve. I have a negative in the absolute value bar, so I have to get rid of that. And the absolute value of negative 8 is 8, so I have a 5 times 8 minus 9. That gives me 40 minus 9, which is equal to a 31, which is true. So this solution is true. Okay, so our two solutions for this equation was x is equal to 3 and x is equal to negative 1. So we've just solved our last absolute value equation.